Data indexing and selection are fundamental operations in data analysis. They allow you to access and manipulate subsets of your data. So let's start off by creating a basic data frame that we're going to be using to play around with. So let's create our dictionary first, which is going to be our student data. Whoops. Student data. It's going to be our dictionary. And here we're going to have a couple of information about the student and their grades. So we're going to have student, and we're going to have a list of students here. So we're going to have Alice, Bob, Charlie, and David. Great. Now we're going to have three specific subjects, which is going to be math, science, and English. So we're going to have math. And for math, we're going to have a list of grades here for each student, which is going to be 85, 92, 78, and 88. Then we're going to have science. And our science grades are 91, 89, 84, and 95. And last but not least, we're going to have English. And our English grades are 79, 85, 7, and 90. Okay, great. And so we're going to create our data frame with pd.dataframe. But before we do that, we of course need to import pandas as PD because we're going to be using pandas here, our library. And we're going to pass in our student data. And we're going to have indexes. We're going to have predefined indexes here, which are going to be just letters A, B, C, and D. So instead of having number indexes, we're going to change them to have letter indexes. And of course, let's take a look at our data frame once we have created it. And of course, we're missing a comma here. And of course, we have a misspelling here, data frame. And let's run that again. And there we go. So now we have this test data set that we basically created here, which is going to be our data frame here. And now we're going to play around with being able to manipulate this data frame and be able to extract specific types of data in different ways. And so one of these kind of most basic things is being able to access column data. And so let's say we want to get the math column values. So we could use the bracket notation. And let's say we have math scores, and that is going to be df math. So if we want to get the values in the math column, we access it using this bracket notation and the name of the column, and then we can assign those values to the math scores variable. And then if we take a look at the math scores, then we can see we have this series basically, which is basically all these grades for the math column. Now we could also have a second option of doing this, and that is using the dot notation. So instead of using the brackets, we could use the dot notation. And let's say we want to get the science column now. So to be able to access that, we will use the df dot and then the name of the column, which is science. And if we take a look at that, then we get similarly like we did before with the bracket notation, but for the science column. If you wanted to select multiple columns, then we would use the bracket notation and provide a list of the names of columns that we want to get. So we could do this df bracket notation, and then a list inside that bracket notation. So let's say we want to get math and we want to get English now. And if we run this, we get math and English. Now, if we want to get the rows instead of the columns, we could provide the numbers of the rows. So similarly, again, we use our DataFrame DF with bracket notation, and then just like we could do with lists, and where we could slice and choose the number of rows or number of characters or elements within a list, we could do the similar way with data frames as well. So let's say we want to get the first 2 rows, so we would use 0:2, and when we run that, we get the first 2 rows, which is A and B. So basically, starting with the first row, which is starting with index 0, then we include the second row, which is indexed 1, and then excluding, we stop at index 2, which will be technically C, so we don't include C in our slicing. We can also select rows based on their labels using the .loc or loc method. So let's say we want to get the first row. So we would df dot loc bracket notation, and then here we provide the label of the index. So in this case, we have A, which is our first row, so we would provide the A label, and we run that, and we get the first row. If we wanted to select multiple rows by using those index labels, we would use the splitting notation, similarly like we did before, but it works slightly different. So again, let's say we want to get the 3 rows B, C, and D. So if we scroll back up here, so B, C, and D, then actually let's do this. DF, run this, and let's say we want to get B, C, and D, these 3 rows. So we do bracket notation, and we start from B, so we provide the B label, colon, and we want to get B, C, and D, so we would provide the D label here, and once we run this, we get these 3 rows. So when using the LOC method, the loc method, the index or the end index is inclusive. Now, in situations where we don't know what the index is, but we know the position, so we want the second, third, or fourth rows, then we would use the iloc method instead. So not the LOC, but the .iloc. And this allows you to select data by integer position. So if we want to get a single row, we do df.iloc, bracket notation, and then the number index. So if we want the second one, which would be indexed with the number 1, then we get the second row. And in this case, it's B. If we wanted to get multiple rows, we would use, again, with the colon, and to what index we want to stop. Now, in this situation, using the iloc method, the end index is exclusive. So when I provide 3, it does not include the third, or technically the fourth row, but with the third index. Instead, it takes the first and second rows, but not the third one. So when we run this, we get B and C, so the second and third rows. Now let's say we want to get specific rows and columns at the same time. So let's say we want to get row B and C, but from the column math, so 92 and 78. So we would do df.loc using the loc method. Here we would want the B and C rows, so we would do B colon C, because we want those 2 rows, comma, and then the column. So we want the column math So we would do the math. So in a similar way, this is the rows that we want, and this is the columns that we want. So we want rows B through C, and we want the column math. And so when we run this, we get 92 and 78. Similarly, you could use this with the iloc method, where you provide the positions instead of the labels. So we can do df.iloc bracket notation, and now the list of the rows that we want. So 0 and 2, comma, and then the column that we want will be position 2. And when we run that, we get science. So 2 is the column 2, so it's 0, 1, 2. So it's going to be science. And 0 and 2, which is the first and third rows. So if we take a quick look again at the data frame, the first element is 91 and the third is 84. So again, 91 and 84. So A and C, those two rows, so it's 0 and 2. And the second position of the column, which is science. Conditional selection allows you to select data that meets certain criteria. So let's say we want to get math scores that are above an 80. So to do that, let's create a new cell. We first provide our data frame with our bracket notation, and then inside that we provide the filtering logic. So here we want to select the math column. So we would do df and then math column. So similarly, like how we selected the math column when we did it here in the beginning, selecting various columns. We do that again here. So we select the math column and we want those values to be greater than 80. So when we run this, we get scores in math that are above 80. And again, let's take a quick look at our data frame for reference. We have one score that was a 78, so it should only be A, B, and D. And exactly we have that A, B, and D because these scores are above 80. And we could do one more where, let's say, science is greater than 85. And when we run that, we only get A, B, and D. So that is also correct. But if we do less than, we only get 1. You can also combine conditions to use multiple conditions using the ampersand sign or the pipe sign for and or. So let's say we want data science or a science score greater than 90, and so we use the ampersand, and let's copy this, copy and paste, and let's say math greater than 80. And when we run this, this is a small error because we also need to put these in parentheses. And then when we run this, there we go. So now we only get scores from science that are greater than 90 and math that's greater than 80. And we see that right here, compared to here where we have math at 78 and 85, 78 and 84, and 92 and 89, which do not fit this condition. Now we could change this to an or, which would be a pipe sign here, where we would have to find conditions that are either scores that are greater than 90 or math scores that are greater than 80. And we run that, we get one more column, one more row here, because C does not fit either of these conditions. So it does not have a score greater than 80, or it does not have a score greater than 90. You can use methods like isIn to check whether a certain element exists within a given list. So let's say we want to check if specific students exist in our list. So let's take a look at our data frame, and we want to look at our student column. And here we want to use the .isIn method. And here we provide the list of elements that we want to check to see if the students column has those values. So let's say we want to check for Alice, and let's check for Alice for now. And when we run this, we can see that it's true for the first row and false for the subsequent rows. So it checked and it sees that it's true and that this element does exist, and so it returns true. Now, if we actually want to see that row, because this is like a filtering condition, we put this in brackets, just like we did in the filtering. So our data frame, bracket, and then the filtering. We can use this information to filter out which rows is true. And if it's true, it returns that specific row. So when we run this, we see it returns the first row because it's true. That element does exist, and so it returns that entire row. Similarly, like we did with the filtering here, if it fulfills that condition, then it will return that element. Because if this was false, and let's say we did Jack, then it returns nothing because all the rows are false. So the condition is not true. That element does not exist within that list. You can use the where method, which replaces values that don't meet the condition with a specified value. And this, by default, is typically replaced with nan values, or not a number. So let's try this. Our data frame dot where, and we want to provide the condition. So again, we use our data frame to select the columns that we want. So let's select math column, the science column, and the English column. And we want to check the condition where the scores are greater than 85. And when we run this, all the scores that are above 85 have been returned, but the values or the scores that did not meet this condition, that were not greater than 85, they were replaced with nan, or not a number, or basically null. You can also specify a value to replace the non-matching entries. So it doesn't have to be always nan. Instead, we could do this. Before this, we first have to select our columns again, where we provide the math column, the science column, and the English column. And let's delete this df dot. And again, we use the where method. We use the same condition, and after this condition, we can provide what exactly we want to replace it with. And so let's say we want to replace it with zeros. And if we run this, then we can see that everywhere where it was a nan, or basically where the condition was not met, it was replaced with the value 0. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.